So you really need to understand how they work. You cannot really have someone else do it for you and then just give me the whole project afterwards. Okay, so it has to be a portion of it. So you have to understand to know how to get a portion of the project someone else wrote for you if you have someone else do it for you. Okay, so any questions? Still a couple people haven't contacted me to go over the um, the second project. So maybe after this class, if you have a time, you can do it. Okay, or just contact me so we can set up a time. So I think that's that. Now, any questions? Any questions so far? We only have 2 weeks. We really have this week and the next week. Okay, so we have 4 lectures before the final exam. Exams on the 21st of December. All right, so that's like 2 weeks from today. So we have 2 weeks, and then over the 2 weeks, we're going to talk about a database today, and then we can finish database next class on Wednesday. Okay, we may be able to finish today, but may well be on Wednesday. And then we're going to talk about JSON, which is how data gets transferred um, between computers on the internet. Okay, that's really a big eye opener. That's how data gets transferred. It's like there's a parallel universe out there. So you will see how almost all the important apps are getting the data from. Okay, how they transfer data back and forth. And then we have next week we're going to talk about how to do multi-threading programs. In other words, a program that can do more than one thing at a time. Okay, so multiple users can use the program and so on and so forth. So so then that will be it. That will be it. Now for the next 2 weeks, we won't be able to cover thoroughly of those topics. So we're gonna just take a look at that. You get some ideas about how those things work. Okay, so just get some exposure to it. And then I will give you some examples and then I can upload the code into GitHub. So if you want to take a look at that, that's fine. But we may, in addition to the project I assigned, I may have 1 or 2 small problems on the final exam that will require your knowledge of multi-threading and or database. Okay, but will be very minor. So if you can understand the lecture, understand the principles, then you should be fine. Okay. Any questions at this point regarding the plan for the next 2 weeks? Any questions? If no questions, then what I'm gonna do is I'm gonna go over the next project or homework, whatever you want to call it, and then we will I will tell you what I expect you to do. Okay, so I'm gonna share with you my screen, and then from there you can see what I intend to do. I try to describe it, but there's a lot of freedom you have. And then this will allow us to move to database discussion. Okay, so let me see how I'm going to, there you go, how to present. So I'm going to present the description of the project. So this way you understand what I mean. Okay. All right, you can see my screen, right? So here's the Java design patterns homework problem set. In fact, it can be broadened to cover database as well. Okay, so you're gonna make a transition if you want to, if you choose to do this, to jump from data structures, which we've been using all the time, to a entirely different way of storing data, and that's a database. So that's what we're going to cover today. So if you want to do that, that's fine. Okay, that would be a really good experience. But if you don't want to do it, that's fine also. Okay, so I'm going to lay out I'm going to lay out the architecture of the application. Okay, then you know where the database will fit into this architecture. Okay, so this project asks you to design and implement a point of sale. Okay, or sometimes people call point of service Java program with a GUI. So you need a GUI, and you have to use Scene Builder because Scene Builder gives you the model view controller. Okay, that allow us to substitute the model part with the database, which we're going to talk about today. Okay, so far we know there is a model component, right? That's where the older Java classes, data structures are. There's a controller, there's a view. Okay, so that's MVC. Now, the model part can be replaced by the database, commercial database program we're going to talk about today. So, uh, so its purpose is to allow a barista to take coffee orders at a small coffee shop called Corner Coffee. I made up this name. Here are the requirements, okay? So I don't know much about coffee, nor anything about making coffee, but so I try to make this sound reasonable. So if it's not right, so let me know, okay? But I think the idea is there. So I want you to strictly observe the open-close design principle. Okay, that's important. So you can't really just make this work. You have to keep in mind that when you have a class, you finish writing, you should never go back, change it. Okay, when the program's is working, if you make any change, you should not go back and change classes. That's called open-close design principle. So the coffee shop can modify its menu because things tend to change, right? So the coffee shop will, from time to time, modify its menu. Okay, what they offer. So we need to design this program so that allow them to modify the menu easily as the coffee shop grows. Okay, because they tend to add more flavors, more condiments, so on and so forth. Also, the program runs on a touchscreen computer system. That's why we need a GUI. Okay, because you cannot imagine the barista have a keyboard and then type in the orders. Instead, it's just a bunch of big buttons and some text. So it's a touchscreen computer system, which is common for point of sales. Um, Okay, you don't have a keyboard. As a result, a barista can only take orders by touching large and simple buttons with a text on them. So on top of the text will tell you this is house blend, this is dark roast, this is decaf, or whatever. Okay, and the prices are worked into it. So when you press the house blend once, that means you order one house blend. If you press it again, then you need a two, so on and so forth. But the unit price for now is $2. But I want you to design the program so you can easily change the price. Change, I mean raise. They don't mean ever come down, right? So you have to store these constants in a way so you can change those values easily without going back to the classes to change. So that means there's a divorce here between the constant, the values, the prices, and the class. Okay, so you have to have like a final constant somewhere stored in a different file. So whenever you need a price for any class, you need to go to that file to grab those variables and its values. So whenever you need to change prices, just change that file. Okay, the file could be elum, could be a interface, because interface can have a constants, right, as a variables, although we don't use that often, but you could. So you could put an interface in addition to methods, but you can also have prices as because all the variables in interface, if you remember, are public static final. Okay, that's exactly what we want. We don't want people go change the prices in the program. Instead, if you want to change the price, you have to go to the file manually to update the price or get a different file. Okay, so in any event, so I want you to keep that in mind. You don't want to write all your classes with the prices hard coded in there, right? Because then if you want to change the prices, which comes quite often, then you're going to have to change all the classes, not all the classes, many of the classes, right? So that's something to keep in mind, okay? So now you are a more sophisticated developer. I think those are things you should keep in mind. It's not 148 anymore, or not 18. Just try to make it work. You have to keep all the things in mind, for adapting to changes later on. Okay, so the coffee shop has initially made it simple. Okay, there's only 3 basic coffee types on its menu: house blend, dark roast, and decaf. So I gave some initial prices here, and those prices are subject to change, of course. Okay, later on. The coffee shop also offers the following 2 condiments: steamed milk, the 50 cents, soy, that's 75 cents. Okay, I don't know if you can even remotely correct or not. All right, because I don't drink any of those. Okay, the POS system should obviously allow the customer to order more than 1 coffee at a time. Okay, because somebody may order 2 coffees or 3 coffees, so on and so forth, or different coffees in one order. Okay, you cannot just say each order just allow limited to 1 coffee. All right. Also, something I didn't state here is you should have a date and a time. Okay, when you create the order, right? When the order is created. Okay, and on the order, you should also have the description, right, of each item, each coffee, what kind of coffee, whatever condiment, and also the price. Okay, and the subtotal, tax amount, total. Okay, so those are unstated, but you should be there. Okay, you should be there. Ideally, if you do a invoice, which I'll ask you to do, okay, you should also have the corner coffee name on top of the invoice. Okay, or phone number, you make up a number. Okay, when each order is complete, the barista hits the big red button marked as order at the bottom of the screen. At this time, 3 things going to happen. The first thing is a ticket is going to be generated. So someone at the counter could make the order, right? Make the coffees or coffees. Okay, because the person who take the order may not be necessarily the person who's making the coffee. Or maybe there's a group, a team, so making all the coffees for the customers at the same time. So you need to generate a ticket that indicates what coffees are ordered, what kind of coffee are ordered, and what condiment to use, so on and so forth. Okay. The second thing you need is the same ticket, right? The kind of information on each order, not necessarily the name of the coffee, so on and so forth, is generated. So perhaps, oh no, not this one. The same ticket is also appended onto a text file. Okay, the text file is called sales.txt under the sales folder in the project folder. Don't put it into F drive, E drive, put in the project folder so it's all in one place. Okay, in the project folder, create a folder called sales, and then in the sales, you're gonna have a text file called sales.txt. So what happens is every order will be appended to that. So this way, every time you just order, this order will be added to the file. Okay, in other words, you can actually just go to the file, you could look up all the cells because it always keep on appending to the same file. You understand? Yeah. So locate in the project folder. And then finally, the third thing is an invoice is generated for the customer. So customer knows what the customer ordered and the items and the quantity, the total, subtotal, tax, so on and so forth. And I gave a tax rate, I think this is Suffolk rate, 8.625%. Okay. Um, okay. In addition to that, to allow data persistency, all sales data, okay, all the sales data should be backed up as a binary file and restored every day. So in other words, all the sales you made um, should be backed up, and then when you restart when you close down the application, restart it, the data should come back to your memory. So it's there. You're not gonna lose it. You follow that? So that's called data persistency. Okay, so you need that. Okay, when the program works, okay, when you display the invoice on the console or on a like say a text area, say if you want to do that, you won't get printed out on the printer, so you don't need to worry about the printer print out. So just show it on a text area or show it on another window. Okay, another stage. In other words, if you want to choose to do that, you can do that. Okay. Now, when the program works, now you need to test your design by adding a new basic type, coffee type, that's espresso. Okay, the idea is when you add a new type, you do not need to go back, change other classes. Okay, so that's the goal. You don't want to go back, change the classes of a house blend, dark roast, or decaf, or something like that. Okay, so that tells you you must have something on top of that, kind of like either interface or super class. Most likely, you're gonna have a super class above these four types. Initially, three types, right? So you can just call it coffee if you want, or call um, um, beverage or something, okay, or whatever you want. Okay, now, so you can add a new basic type, and also you can add in two new condiment types, mocha and whipped milk. And then espresso is $3, mocha is one, whipped milk is 50 cents. Okay, so again, this you can add all these without affecting the existing stuff. Okay, the other classes. Okay, so you can tell we talked about this. We need to use maybe a decorator to do it. Okay, so you can wrap when you add more stuff to add more layer. Okay, when the program works, test your design by adding a sandwich item, which is not a coffee. Okay, so now you have a design because a coffee shop may decide to sell sandwiches, right? And then that should go on to the menu as well. And then when people order, they could potentially order sandwiches. Okay, now of course there are all kinds of sandwiches, but we just make it just one general sandwich like bacon and the cheese and something simple. Okay, egg and cheese. So you don't need to be more fancy than that. Okay, but they can make one or two, three, whatever number of sandwiches. All right. So now you can consider using some of the or all of the following design patterns: decorator, singleton, observer, facade, factory, composite. So those are things you can consider to use. Model view controller is a must because that's already built in here. That's why I said you have to use scene builder. That's a model view controller. But then you probably have to use decorator. Okay, you definitely to be nice. You may want to use a singleton. So your data structure can only have one instance. Say you decide to use a tree map or decide to use a tree set, whatever you want to use. Okay, you want to have only one such a data structure. You do not want a multiple tree maps to hold all the different orders. The order should be in one place, in other words, okay, in one data structure, which is reasonable. That's what you do already, right? Right. But to ensure this happens, there's only one tree map, or somehow, trees, or order store, so to speak, or order container, whatever we want to call it. Then you may want to have a singleton observer. When you complete the order, hit the finish or order button, then the three things are going to happen at the same time, right? Remember, generate a ticket, generate the invoice, and then append the data to the text file. So that could be observer. So there are three other observers watching the observable. Okay, so something you can consider. Facade. Okay, when you press all the buttons, right? When you press all the buttons, when you order, you say house brand, and then if you hit, say mocha, okay, or hit some steamed milk, then those can be uh, put into the same facade method. Okay, then they'll be used to build three objects, one wrapping around another. Okay, because house brand is one simple object, and outside it you may have a steamed milk, and outside of that you may have a mocha. So so that potentially could be a facade data structure, or you can have a factory, okay, and composite. Now, because you have sandwich also, so you may want to have a composite. So this way, the sandwich and the coffee can go to the same data structure. They can behave the same. They can print the same. Okay. Yes. So consider those. Consider those. Right. So now, how you're gonna do it? I'm not going to talk too much about it. I just tell you that the principle is, you try not, whenever you add new stuff, you try not go back to change existing classes. Also try to separate the price from the classes. So whenever you update the price, you won't have to go back change those classes. Okay. So also you may want to have all the prices in one file, in one class or one interface. Okay, so whenever you want to update the prices, usually they don't update one item, I imagine, right? When they decide they want to raise the prices, they'll raise a lot of items. Excuse me. So they're going to raise prices for a lot of items. So it's easier to go to one file, okay, an interface or superclass that contains contains all the or ELAM that contains all the prices. Just go to that file, update that, then you're done. Okay, next time when you run the same program, the price will be updated. All right. So, question, yeah.
All right.
Mhm. I'm sorry, I didn't hear your
Oh,
question.
sorry. They're not gonna be able to update the price from the GUI, right? It's just gonna be from the
Yeah,
uh,
that part you can go and just add a price on the file if you want. Okay, you don't have to update the GUI. Yeah, but if you have the time, yeah, have an interface, have an interface that you can actually update from the another scene. Okay, so a button, you click on the button, not click on the button, hit the button, then another thing comes up, then you can update the prices.
Quick question, Professor.
Mhm.
On the point F, you said that we have to back up the data, but
Mhm.
so you want us to allow the barista to be able to look at all the sales that have been done before, like in previous days as well?
Well, backup data, just whatever data in the data structure, say use a tree map or tree set, whatever, needs to be saved as an object onto the file, onto the hard drive. And then when you reopen the application, the data will come back from the file. So the tree map will be rebuilt.
But then I guess you want us to, because you said I don't understand, because usually when you load the program, you load all the, I guess, like the items of the menu and that kind of stuff. The only stuff that would make sense, at
The
least to me,
sales as
is
well.
like the sales,
On the
yeah.
sales as well, yeah.
So you want us to allow the barista to look up the sales from
Right.
previous days? Okay,
Because
okay.
because with all the data in there, at least you can look at the sales value for yesterday, for 2 days ago, for last week or last month, so you can all look it up. Okay, but also at some point you're gonna have to dump the data because at the end of the month maybe or end of the year you want to dump all the data into a file, then start from scratch.
Okay.
All right, but don't consider that. Just right now, just keep every data in all the data, all the orders in the same data structure, and keep on going. All right, good. All right, other questions? Now you have to think about data structure, right? And what what data structure to use. Now the number of orders is unlimited, so data structure should take that into account, right? And also you want to consider that each order should have an ID number, a unique ID number. So when someone come back with a receipt or invoice, and the invoice should have the ID number, so you can look up that sale in your record. Okay, so it has a date, has to have a unique order number. Don't forget that.
So tree set.
Yeah, so now this time you're gonna have to decide is a tree set or tree map. Since you already have ID, every time you place an order or a customer place order, you generate ID, right? Right. So so then you can have um, a potentially a tree map, right? Because ID will be the key and everything else will be the value. Okay, so that's a possibility, and that gives you good performance. Okay, so in
Uh,
the future, whenever you search for things, you will search by the ID. Somebody comes back complaining about an order, then you look it up and then look up the ID and they can search it. Okay, so that's a possibility. So you're gonna have to design and consider all that. You probably do not want to use a hash map because you do not know how many orders you're gonna have in a day or in a month or whatever. Right? Makes sense. Okay. So then you must have some mechanism you can tally. Okay, you can tally the orders and the number of say number for in each order, right? You have to have a variable to hold how many house blend and how many decaf, how many mocha, and so on and so forth. Okay, because you need all that to be put on the uh, invoice, right? Receipt or on the ticket. So the baristas on the counter could make them. All right. So those are things that you have to consider. I'm sure you have that experience. Okay. If you're not a coffee person, you can think this as a bar. Then you can convert all the coffee into alcohol drinks. Yes?
Quick question, Professor. You said how we should have an ID for each order. On
Yeah,
some restaurants, I don't know how much is the limit of digits that they have on the ID number. Like some orders have a length of 8 digits or 10 digits for
that's
the
that,
order.
that's easy, right? So you can start from 0, so 8 zeros, then 7 zeros into 1, 7 zeros into 2. So yeah, so that's easy, just the format. You don't have to worry about it.
Yeah, so like we don't have to worry about reaching a limit. Like we used all the numbers on all these 10 digits, right?
Or what?
Like for
You
example,
can keep
like
on going, right? Even from 0, 1, and all the way to million, billion, trillion.
we don't have to worry about like those specific cases that will reach the end of the how many orders there is, I guess. Because you said we're gonna start all over from in a month, right?
You can use an integer as order ID, and then integer can get you 2.1 billion orders. I guess that will take a while for a
Yeah,
quarter.
but that's okay for as a design way of thinking about it, right?
Yeah,
Okay.
that's
It's
not a
just
constraint. That's not
that's
an issue.
that's because I usually think about it like one day eventually you're gonna reach that billion, and you should have an answer for that already.
Yeah, at that time, then you'll be dead. I will be dead.
All right.
Okay. So let's not worry about that. There's a lot of things you can worry about. The format, what the receipt looks like, the tax, how, the tax has to be 2 decimal digits because of the price, right? So you don't want to have a number and the calculator be 15 digits long after decimal point. Okay, so those are things are automatic. You need to know. Okay, sounds good. 2 weeks. Yeah. I think after this, or maybe even for this, you should feel comfortable develop some apps, right? Because we did one, this is somewhat different, but it's the same, really data structure, right? You have a model view controller, right? Except that maybe you decide to use a different data structure to implement it. Maybe now this time you go one step higher, more advanced by incorporating data the design patterns, which we didn't do last time. And that's it. That's the end of this course. That means in the future, any kind of application, you know how to do it. You need to pick data structures, you have to put them in the model, and you need a view, and then you have a control in the middle, and everything else is just a detail. You know the big architecture already. Right. So if you can finish this in 2 weeks, I mean, you do it in 2 weeks, not someone else do it for you, then I think it will be really good. You should be very, very comfortable moving forward, and you can do this in so little time, and you can do anything, especially if you could try to replace the data structure with this database we're going to talk about today. That would be even more fantastic. All right, and of course you can make the GUI look nicer. Okay, just consider this is the point of sale. You've seen those, right? The point of sale, usually you don't have a keyboard, it's just a touch screen. You press those buttons. Yeah, I don't think they have a keyboard, right? I never seen them have a keyboard. It's all touch screen nowadays. All right, any questions? was fun. Then that'll be it. That for the whole study at the Suffolk. That's a good closure. That's exactly what we intend to do. When you finish here, you can either go to industry or transfer to a 4-year school. Right, that's our intention, and you feel competent enough to do anything. So we just did a trail hiking. Now this is a coffee shop. I think that maybe the last test. Good. All right. Okay, so you don't have questions then? I posted this already on Piazza as well as your Dropbox. I made the deadline to be December 21st, 12:30. Okay, so that means you need to submit by that time. Okay, after that time, the Dropbox will be closed, so you cannot submit anymore because after that time, our final exam starts.
No, it's 11:59 actually. So we got a few more hours.
Is that right?
Yeah, looks like it. It's just
Okay, I will change it. Make sure it's before the exam. Okay, before 12:30 p.m.
darn.
Okay, so you cannot submit afterwards, and then you should keep a copy. And also, since you did it yourself, I may just ask you a small part of it. For example, in the final exam, I may just ask you to code the classes, the decorated part of it. Okay, rather than the whole thing. Or may just want you code the part that prints do the three things: the invoice and the receipt, and then the backup or the ticket generation. So it will be, in other words, it will be a small part of the whole thing. So if you do it yourself, then you will have no problem. And then I will try to make the final exam easy. As long as you did the work yourself, then that should be easy. I don't want to give you too much stress. And that's before Christmas anyway, so I want you to be happy and enjoy Christmas or whatever holiday you celebrate. Kwanzaa, maybe. Okay, so so that's it. You good? No questions? All right, if no questions, then I'm going to talk about a database today. Database, I'm going to start with some kind of diagram. See if I can draw some diagram for you. So T48. Okay, so I'm gonna draw you some diagram. So far we use the model view controller, right? Okay, model view controller, MVC, and then we have a component that's called a view, right? Okay, and then the view goes through a controller. Okay, so data back and forth, and then we have something called model. Okay, so model is the data. So if you have a data structure, the data structure should be inside the model, correct? Yes. So if you use a tree map or tree set, and then that should be inside the model. Okay, so here is, say, you're going to use a tree map. Okay, so that will be inside the model. You don't really directly use a tree map or tree set. Instead, you want to have a, like, say, order store or order container, and inside that you use a tree map, because you don't want to expose the whole tree map. The tree map may have a lot of methods that could potentially be used, but if you embed the tree map inside a order store or order container, you only expose certain things you allow users to use, rather than directly expose the whole tree map, right? So anyway, so that's the data structure holding all your orders, right? Okay. Now, that component can be removed, and be replaced by an entirely different module. Okay, and we call that a database. Okay, now database is a specially designed software package meant to store data. So it's optimized for storing data of all kinds. Okay, so there are companies, all they do is develop such a software package, okay, software, to allow you to store data. Okay, now how they do it, they could use tree map or tree set, they may use linked list, whatever they use, because that's the real underlying data structure for database. Okay, or they may organize the database by using documents. In other words, your data is not in any kind of data structure we are familiar with, not like a map, not a tree, instead, your data we put into a series of documents. That's also possible. So whatever they need to do, but they do it with the consideration that they want to provide the best efficiency, best flexibility, okay, for storing all kinds of data. So they can be used universally, in other words. Okay, so many companies do this part. Okay, so examples are, of course, the biggest of all is Oracle. Okay, Oracle makes tons of money by having the database called Oracle database. Okay, Microsoft has the product called SQL Server. SQL Server, very, very common. So those two are most common in the commercial world, in companies, businesses. Smaller ones tend to use a SQL Server because it's cheap. Large ones, like I don't know, like the utility companies, like they have a large database, multinationals. They may use the billing program, right? Custom management of the program. They tend to use Oracle because Oracle has longer history, was meant to handle a lot of records, a lot of data in its database. So these are two most common commercial product. One's called Oracle database, one's Microsoft SQL Server database. Okay, now Microsoft is catching up. If you ask them, they say they are just as good as Oracle, but they are a lot cheaper, maybe 1/10 of the price of Oracle. if you use theirs. So as a result, Microsoft SQL Server gets really, really popular, but they all both charge you money, okay, for commercial use. If you want to use for nonprofit or just use to learn, then they have a free version. Usually it's called a community version. Okay, you can use, you can download, you can use, except that you're not supposed to use it for profit making. Okay, so Oracle has a community version. Microsoft SQL Server has one as well. Microsoft SQL Server also has one with a license like a 1 year. You can use it for free, even for profit making, and afterwards you have to pay. So anyway, those are commercial products. Then there's another product is called a SQL Server, or it's called MySQL Server. I'm sorry, MySQL, and MySQL is free. Okay, it was free, and then a few years ago it got bought out by the company Oracle. So now Oracle owns MySQL. Okay, but Oracle now made MySQL a community version as well. So that one is free. Okay, but if you want to use MySQL for business, you still have to pay, but this time you're going to pay Oracle. Before Oracle bought it, it's all free. Okay, so MySQL is very, very popular because it was open source. Okay, so people use it for free for many, many years. And so it's very popular. Okay, now there are many, many others out there. And the one I'm going to show you is called SQLite today. SQLite. Okay, SQLite is a very small, very lightweighted database program. Okay, it's used mostly for mobile apps. Okay, it's used it works just like a file. I want to show you. It's like a regular file, like a Word document. Okay, so it's fairly easy to use, very lightweighted. So if you want to use a SQLite in your application, it's not going to increase the size of your application by much. The file size is very small, very tiny. That's why it's popular among mobile applications. Okay, now in addition to this, you have tens at least of other database programs out there. Okay, but these are the most common ones. Okay, now you notice all this except Oracle didn't say it. All these databases are called SQL databases, SQL. And SQL stands for structured, S is structured, Q is query. Query means this program will store data, then you can send in a query, means a request. So the program, like a black box that holds the data, will return the data to you. Okay, so it's a structured query language. Okay, so all these databases, even though they have made by different companies, some free, some for a fee, but they all use the fundamental principle is they use a language called a SQL to interact with. Okay, so this is one type of database we call the SQL database because they all use this kind of a language, SQL language. Now, the SQL language used to be one language, but then the different companies make small changes to it, so they have a different variations, slight variations between Oracle, Microsoft SQL Server, MySQL, SQLite. So they are a little bit different between those software packages. Okay, but overall they're very similar. The language is called a SQL. Okay, structured query language. Okay, now if you need to interact with the database, that's the only language you have to speak to interact, called a SQL language. If you don't use a SQL language, then the database is not useful at all. Okay, you cannot communicate, cannot interact. Okay, so that's a SQL. Now, in addition to SQL database, there's another category of databases, and they call NoSQL. NoSQL databases. Now, by definition, NoSQL database means they're not using the SQL language to interact. Okay, instead, it doesn't, in other words, it doesn't use SQL language. Instead, it stores data in a very fundamental different way, and they call documents. In other words, all the data come in just stored as documents. Just like our files directories contains documents of all kinds of essays, stories, whatever, writings, Excel files. So they're all just documents. They're not structured. Okay, but the reason there's such a thing called the NoSQL database is because there's a lot of data structure, a lot of data are not structured to begin with. Say the songs, you want to store the songs, they're not structured. Songs are not structured. They just sound, right? And if you have movies, they're not really structured. Okay, there's the bits and bytes in make up a movie. Okay, they don't have say that you cannot say you have a string for name, a double for GPA. It's not like a student. It's structured with a name, with a GPA, with the ID, so on and so forth. But the songs, if you look at songs and movies, they're not really made of those things, made of those variables. If you play a song, basically just a bunch of bits and bytes and make up the sound. Okay, so in that kind of case, we would store those data in a document, just like a what they call like a movie MOV for the movie, right? Okay, and for the video, what do we call them? MP4s. That's another one, right? So when we store movies, usually the MP4s, like if you upload your movies or your video footage or clips onto YouTube, usually they take MP4s. Okay, so that kind of data is not really structured. So it's better to store it as a document or as a file, in other words. So those are called NoSQL database. Okay, so so there's a whole different category of database software. Okay, so one of this example is called MongoDB. Okay, that's NoSQL. It's a document based. Okay, the company actually I think is in New York. I think somehow I know a student graduated from our class a few years ago, worked for MongoDB. Yeah. So, and his office in the New York City. Maybe I don't know if that's just a branch office or that's the headquarters. I don't know. So, so those are two big categories: SQL database versus NoSQL database. Okay, so of course, the SQL database is older, been around for a longer time, so it's used very common. And the one we're gonna look at today, SQLite, is of course, kind of SQL database, not the NoSQL. Okay, now the only language this database can speak is SQL, right? Okay, now when you have a Java, that means you're going to have Java classes, right? And the classes, we used to have a class called, say, order container or order store or trail store. That inside we have a data structure, right? Like tree map or tree set, correct? Or array or linked list, whatever. Now, those store programs or container classes will now need to interact because they don't have the tree set tree map anymore. Because we're not using tree set tree map to store data anymore if we use database, right? So instead, so those container classes, like the store classes, is instead of have a tree map inside, they will interact with the SQL database. In other words, whenever the container needs data, in other words, to retrieve data, or if the data container or data store needs to insert data or add data to store, the data either have to come from the database the SQL database or will be going to the SQL database. Because you don't have a tree set tree map anymore. You don't have local data structures anymore. Now data is stored entirely on a different file, a different structure. So what you need is in each container, you have to have statements, Java statements, that can interact with the SQL files or SQL database. But since the SQL database can only speak SQL, then that means you have to speak the Java container, the data container or data store, has to speak SQL as well. Does it make sense? Right? Because if you want to interact with the SQL database, and the SQL database only speaks SQL, that language, structured query language, then that means your Java program has to speak the language as well. Right? Otherwise, SQL's database will not understand you, right? Understand? So that means all the SQL statements which SQL database understands has to be embedded into Java language. So when we write the Java, we have to embed the SQL statements. You understand? Okay, so when we write our Java code has to contain some strings, like double quoted strings. And those strings are really just SQL statements. Okay, so in addition, you must have a translator in the middle that can take the Java strings, i.e. the SQL statements, okay, and send them to the database directly. Okay, or when the data come back from the database, the middle part needs to be able to interpret data and formulate the data for the Java container. So you need some kind of adapter in the middle, doing this kind of translation from Java statements embed with SQL statements embedded as a string, translate those into SQL statements so SQL database can understand, vice versa. Okay, so this piece of software who does this kind of a translation is called SQL driver. It's a driver software. So we need that driver software to make it possible for our Java container, Java statement to send in SQL statements for SQL database to understand. So we need another piece of software called a driver software. Okay, now the driver software is different for each of this database software because each one is slightly different in terms of SQL. Each one has a slight difference in dialect. It's like a dialect. So that means the driver has to be different. And also each of this database program is implemented differently. Some may decide to use a tree map as its underlying data structure. Some may use a tree set or hash map, hash set, whatever. So they made their own design. Okay, so that means every of these programs driver is different even for Java. So that means if you want to use the Oracle database, you have to have a Java driver for Oracle. If you want to use the Microsoft SQL Server, then you need a Java driver for Microsoft SQL Server. Same thing for MySQL, same thing for SQLite, SQLite. Because there's always a slight difference of this software. So even though you're using Java, but the adapter or the driver has to be different. So you just have to make sure you download the right one. Okay, you have to make sure you download the right one for the right database. All right. Okay. Now, so that's a simple driver, right? That's a simple driver. Good. So we're gonna have to download that. Now there are companies go more extreme. What they do is they so let me expand this. So this is your SQL database, right? Whatever that is, Oracle, Microsoft, whatever. And then this is your Java. This is your Java model. Mostly now you have those containers or stores, right? Usually we have tree set, tree map inside. Now instead, we just have Java statements that we hopefully interact with the SQL database, right? So there are companies go more extreme, and they build another big box in between. Okay, we call that JPA, Java Persistence API. Java Persistence API. Now, Java Persistence API has different model of those driver built in. That's the essential part of it. Okay, but most importantly, when you need to have your Java code to interact with your database, when you need that, you do not need to know anything about the SQL language. You don't use SQL language. It's unlike the last case. You have to embed SQL statements in your Java code as string, right? As before. Now you don't even need to know anything about the SQL statement. Instead, you just use the JPA's statements, the Java code, like a getter setter, like a search we used to do, or find, or contains, those kind of methods, which has nothing to do with the SQL statements, the pure Java statements. So you send those Java statements to JPA, and JPA will translate your search method, your insert method, or add method, or whatever method you have, translate into SQL statements. and then query the database. So over here is a pure Java. So that's your Java model interact with the JPA. But JPA will translate, understand your intention, will convert the Java statement into pure SQL statement for you. So because of that, the Java developer or Java programmer does not need to know anything about the SQL. You just totally rely on the JPA to do it for you. In other words, you don't even need to learn a new language. Do you understand the idea? One is you have a SQL database, you have a small box called a driver, okay? And then you have your Java model, okay? So when you try to interact with the SQL database, you have to embed the SQL language statements in your Java code as a string, as a regular string surrounded by double quotes. So in order to embed those statements, you have to understand what you try to do. You have to understand the statements, the SQL statements, so you can embed them. And then the driver just purely translate it, send it to SQL server. Okay, so that means you, as a developer, you have the responsibility to understand the SQL and formulate them in the syntax, SQL syntax, but save them as string. You got it? Or you could rely on JPA. That's a bigger box. And what it does is it provide you with the APIs. So you as a Java developer, you don't need to know anything about a SQL. You just use the Java methods like contains, size, and get and set, insert, search. Those things we did when we do the bags, or when we did a tree set, a tree map. And then the JPA will do the rest for you. Will convert your Java statements into SQL statements, and then we interact with the SQL database. So these are two solutions, and both are common, very common. Okay, good. All right, any questions so far? No questions? It's kind of irony because we spend so much time studying data structures, okay, in real applications, big ones. Usually people use a database to do it. You don't even need to use data structures we learned. But for small ones, yes. But the reason we do learn them is because ultimately someone has developed the database program that has to use these kind of data structures. So if you are doing the Java part, you don't even need to know anymore because someone already did it over here for you to store the data. Okay, so it's still very good. It's important to understand how data gets stored, how tree map and tree set work, or hash map, hash set work, even if we don't use them directly, but they are used. They are used. All right. So for the project we were talking about earlier today, if you want to add this piece, that's great. That's the database piece, right? If you don't want to add that piece, and then you can go back and use the way we did in the trail, the hiking program, and then you just use the tree map, tree set, whatever you decide to use. and use those to store data in your in your data store or data container. Okay, but in real world, people usually don't use those data structures. Instead, they will rely on databases. Okay, so in other words, someone else have already created the packages or software packages that are already using the data structures, and we just have to use it. We don't have to implement ourselves. But in order to do that, we have to learn the language, which is SQL. If we don't want to learn the language, then you have to use JPA, Java Persistence API. Then you don't need to learn the language itself. And the API is another program that will translate it for you. Translate the Java statements into SQL statements. All right, so now the first thing we're going to talk about next is where we're going to download the drivers. Okay, remember we're not going to talk about a JPA. Okay, what we need to talk about is, with the time we have, we're going to talk about the drivers. Why? Because when we use the drivers to do our program, then that means we need to use SQL statements, right? So we have to embed a SQL statement into strings in our Java containers, data containers. So that will allow us to see what the statement look like. So it will have some idea what the the SQL statement look like. Okay, if you use the JPA, then you never get a look at what the SQL statement looks like, because JPA does everything for you behind the scene. All right. So what I'm going to use next is I don't need this anymore, so I can close this. But before I do that, I want to go to SQLite. I'm going to show you. So here is SQLite homepage, used very broadly in, especially for small applications, mobile applications. See, there's a SQLite homepage, SQLite.org. That's where you're gonna download this is open source. You can download the driver, okay, and and then you have some tutorials, how to create a new database, and how to install it, and then appropriate uses for SQLite. Because SQLite is very special. It's called on-disk file format, on disk. So the database is just as a file. It's just like a text file or binary file that you use to store data. So we're very familiar of that, right? So, and also it's very small. Its SQLite is 699 kilobit. Very small, not even 1 MB. Okay, so tiny. So that's why it's really nice to use it for small mobile apps. So when people download the apps, they don't have to download a lot of stuff. Okay, it's a small thing to download. Okay. It's not a client server database. It's embedded in the program. So the file SQLite is embedded in your program rather than a client server. What I have here, this, right? This is called a client and the server. So we are the Java, we are the client. The database is a server. That's a client and server. So when we need to store anything, our client have to send data either through JPA or through driver to the server, right? When we need the stuff, need the data, when we do search, then the server will return data back to the client. And the same database can be used to support many clients. See, you can have many hundreds of thousands of clients, Java programs using the same database. Okay, so that's why those traditional common SQL databases are called a client server, but the SQLite is not, is embedded into the end program. In other words, in reality, the SQLite is embedded in here in your Java, just like a tree set and tree map. Okay, so you don't you do not need all these separate program anymore. It's just one file you embedded into your data store. That's it. Nothing more than that. So it's easy to understand, easy to use. So that's why very popular, very small, tiny. Okay, all right. So first thing first, we need to download SQLite the driver file. Okay, because that does the translation. So we're gonna say SQLite. Okay, driver Java. We can say driver Java download, or you can say Java. So you can find that. So for example, those are all the driver. Okay. Excuse me. Okay, so many places they it's open source, so it's free. People put in different places. So all those are places you can download. So for example, you have a JDBC driver. Okay. So JDBC stands for Java Database Connectivity. So that's the name of those drivers. Okay. So Java Database Connectivity driver. And usually they come as a jar file, .jar. Jar stands for Java archive. So it's a Java compressed package. So that's what we need. That's the piece that will help you help your Java program to interact with the database. Okay. Now we don't have the database yet. We just need the driver. Then we can create the database. Okay. Database is just a file. Very simple. So you can go in here to download, and you will see download SQL JDBC driver. The latest version is 3.27.2.1.jar. Okay, so that's the latest version. So you go to download the page to download the page. What happened? It's a dead page. The link has no power here. We'll go back to your dashboard. Maybe they that link. No, they put it into a GitHub, like a Git bucket. Let me see, find another download. Okay, somehow this is no longer there. So let me see if I can find it from here. Yeah, so here you look for the jar file code. You can download the whole thing, but let me see if we can just get the driver here. See sample download, SQL library, database file. Then I plan the library Java, release the version, download on Maven. Okay, see if I can get it. Download all SQL library. Okay, so here is a jar file. You see this? This one has the high, even higher version. You see, it's a 3.32.3.2. Okay, jar. So that's the jar file. That's the driver you need. So let me see if we can download it here. Here it is. You see? Do you want to keep? Yes, I want to keep. So 209 megabyte. Show in folder. I downloaded into here. I was downloading some music. So that's the file. Let me put it in my desktop maybe. Okay, so I put on my desktop. So that's the file you need. Okay. I got this from GitHub. Zerio / SQLite JDBC release. So this is the most recent one, 6.88 megabyte. There are plenty of other places you can download. All right. So once you download it, you just need to create a Java project as usual. Okay, create a Java project. So I created one before I start the class. And then I need to, when I already had an older version of the Java file, that's 3.18. The one I just downloaded is a lot, that's a 32, right? 3.32. This is 3.18. So I'm going to import the new one. Import the new one. You must have the driver to make the database work, okay? So what I do is I create a project, just a Java project. I call it JDBC SQLite. I'm gonna go to the thing called build path. See build path. Okay, and then you go to configure build path. Configure build path. And then you see this is my older one. You didn't even know where to find it, so it's missing. So I'm going to edit it. Okay, I'm going to delete it. Actually, let me just delete it, remove it. So under the libraries tab, you see, then there's a class path, right? Under the class path, this is old, so I have to change orders. So I'm going to add external jar. That's what I just downloaded. Add external jar. Okay, then I will go to my desktop, find my 3.32, the one I just copy paste over there. So this is one I need. Okay, or I can cut this. Okay, I can cut this, and I can put directly into the project, and then import it. In other words, go to my project. So the next time when I, import it, then I have everything in one place. So go to my course repo for 248, and then the SQL database there. You see, that's my project, right? So I'm gonna put into here. That's my old one. So I'm gonna put into here, paste. Okay, so I paste in there, and I don't need this old one anymore, but I can keep it there. Okay, that's the executable jar. Okay, now I'm going back to here. See the class path? I'm going to add external jars. And I go to my project. That's where it's located, right? Because I paste it in there now. Into my SQLite. See, that's a new one. I will have the old one as well, but I put the new one. Okay, so I'm going to say open. Okay, so this one is correct. So if I edit, I think I can edit. So just go to this project folder to get it. rather than go through my C drive. Because the next time when you go through this, you may be in a different place. The absolute path is no longer right. So let me see if I can do the differently. So instead of use this, I can just say the project. Okay, so that's my project name, right? So this will be inside my project. So next time when I import, the path should be right. So let me see, open this one. No, didn't update. So let me remove this one more, just to make sure. So go back class path and add external jar. I would like to add as like a relative path rather than a absolute path. So I just want to relatively where I'm located. So next time I'm gonna copy the project around, everything is in the right place. So I'm gonna say open. Now it won't let me do that. I have to give it the absolute path, starting my C drive, users, and whatever documents. Okay, that's fine. So I have to update my Java. That's an old Java 13. So edit. I'm gonna use my 15. And also I'm gonna get my user library in for JavaFX. Okay, because I'm a JavaFX program, so I'm gonna remove that and remove that and add a external jar. No, not external jar. Add a library. I'm sorry. Add a user library. Add my FX library. So that's what I created before. So now I have everything I need. So I just want to leave this here for a few seconds, so you know that you need to make sure you have the JDK set up under the module path. And in this case, I have Java 15, so I have my JDK 15. And then the class path, make sure you add the SQL driver jar file, import that as external jar, and then it gives me the director path, which is annoying. And then I also imported the my FX library, okay, because I use JavaFX. Then I said apply, apply and close. Okay, so these things are good, right? See, I did I remove that? I forgot. I should have deleted that first. That one I don't need. Instead, I need the new one. Delete it, yes. Okay, so let me do the new one again. I'm so sorry, I didn't remove it. So let me just go to build path again, configure build path. That's 32. Apply. And apply close. Didn't show up here. Okay, by the way, I have to figure out why it's not showing up. That's JavaFX. Oh, under reference library, I believe. There you go. So it's now under here now. They moved, I remember now. They used to be put directly under the project. Now they put under reference libraries. So this is 32. That's the latest one. Okay, and it also tells you it's under my C drive, give you the absolute path. That's why if I copy this file to give to someone else, the project, compress it and give it to someone else, it won't work there because that director path is no longer correct. So when you submit yours, if you send to me, I will always have to come back here to change the library to make sure it's referencing to my jar file, not the one on your computer, because the path is no longer correct. The path is use your computer path, not mine. Does that make sense? Okay, so so that's library and all that. So that's good. And I have everything, I think. And now here are the two databases. I have two databases. One is called studentdb.sqlite. Another one I call studentdb1.sqlite. So I have two databases. Okay, in this case, I just need one, but I have two, so we can take a look at both. Okay, now the database files usually, remember I said earlier that the SQLite is embedded in your application. So that's our SQL database, not here, not a client and a server, not a separate program. It's just a file embedded in your application, right? That shows you clearly that that's the thing. See, I just need one. So this embedded in mine is not a separate server running on your computer. If you use Oracle or Microsoft SQL Server, you need to start a separate program. The separate program is there running, and then your Java program has to communicate with the separate running program on your computer or on another computer to talk. So that's called, I don't know if you understand it. In other words, if you use Oracle, then this piece could be, it is not could be, is another program running on your computer or on someone else's computer. It's like a program running on its own, have its own memory, has its own life. And then your job is just to connect to that program. This is almost like a web server, like our school has a web server, right? Our browser from home can connect to it. Okay, that's client and the server. Web server or a browser is the client. So the server has to be running on either on your own computer or someone else's computer on the internet. Then our Java code just have to connect to it. But the essence is an independent program running on its own. Okay, but in this case, it's not the case. This case is our database is right embedded in our application. There's no need to another program running anywhere else. It's right in here. That's why it's so commonly used in mobile apps. Okay, now all we need is this, okay? Is the Java we installed and download and install. All right, what I'm going to show you is here is the code and the SRC. Okay, let me see. I have a main. Okay, here. Okay, here is a program. Let me minimize this. Okay, now you see, this is the main class, right? Main class, and that's the main method. And there's no GUI, but I just want to show you, use this as an example to show you how your Java, that's the Java code, you see that? That's all Java code, right? Packaging, class, method, Java code. And what I'm showing you here in this method is how we're going to connect our Java code with the SQLite. Okay, now it's going to connect with the student DB. You see the student DB? That's the database. That's this one, the first one. Okay, in other words, my Java code here is going to connect to this database. Okay, because the name of it is a studentdb.SQLite. You understand? Okay, now if I show you the other one, this is the simple, right? If I show you the application, and the application I have, I think is under model. No, connection. You see, the other one is a little bit more complicated. This one actually has a GUI. Okay, this is very simple, no GUI. The first one simple, no GUI. This one has GUI. This one has GUI. You see, it connects to the second database, student DB1. That's this one. Okay, and this one is more complicated. You see, there are more files, more classes. You see the XML, that's the view. and you see the controller, login controller, you see the model, right? And there's some utility method to make the connection, basically. Got it? Okay, so the simple one connects to the first database. The second one connects to the second database. Is that clear, or you want me to explain again?
When you create the those files, that studentdb.sqlite there,
Mhm.
is that just created when you start adding to the database, or do you have to create those yourself? Like, is that just created when you put
You
in the
could do either one is fine. You could use your Java code to create database, or you could create a database outside of your Java code, because this is a file. It's just a file, like Excel, Word document is a file. I'm going to show you another program that will allow you to create database outside of it. Okay, and that program is called SQLite Manager. Okay, that one will not only allow you to create database outside of Java, it will also allow you to create and visualize, manipulate all outside of Java. So you can actually see the structure of database. It's called SQLite Manager. It is a Chrome extension. Okay, so we won't have time, but we're gonna have to talk about this next time. So let me go to Chrome, right? So you have to go to Chrome, and I'm gonna go to the thing called SQLite Manager extension. You see, SQLite extension, Manager extension, and it works for both Chrome and Firefox and Edge. Okay, now if you go to it even tells you how to use it. So you can just go to extension, SQLite Manager extension, and it will take you to the many things, but it will take you, this is the Mozilla Firefox, has its own, and then that's the Google SQLite Manager, or you can just the Google, what they call Google App Store, or Google Play, right? So Google Play SQL extension. So you can download that and add, see, Google Play SQL Manager. So it's everywhere. It's everywhere. Initially, it was used by Firefox, then Chrome uses it, and okay. So you just go to Chrome, or whatever you do. Okay, so you can go to here, Play, and you see the install. Okay, so you install it, then this will be added to the Chrome or Edge if you use Microsoft Edge or Firefox. Okay, so once you have it, you will have something like this. See on top here, if I move my cursor here, you see SQLite Manager, because that's the extension will show up. Okay, so the icon might look different because mine is older. This is newer. So you can install. I don't know if it will replace mine. Either way is fine. So I can just install.
I think that one is for a phone, isn't it?
Is that for fun?
For like mobile app, because Google Plays for mobile. There's like I
No,
think
this
for
is
extensions.
for the browser. It should be Google Play. Or you can just do this. That's what I do normally. I just go in here, go to more tools, go to extensions, you see? Okay. Go to browser, go to more tools. Okay. The three dots, right? Then more tools, go to extensions. Then once you're on the extension, you search SQLite Manager. You see? That's mine. SQLite Manager. Okay, so I already installed. That's why it only gives the option to remove, and actually it's also enabled here. You see this is checked. Okay, so I have it. So once you have it, which I already have, then you click on it. Now you have this interface. It's web-based. There's nothing to install really. Okay. Okay. So so that's where you can look at it, and then that's something I had before, so I don't need this anymore. I can close this. Okay, so here you have a new, and then there are some sample statements. Okay. Okay, so there are some sample statements, right? This is database one, which you haven't saved yet. So this is database one, and then these are the SQL statements, if you've never seen one. Okay, this is a sample one. Okay, we're gonna get rid of it. I'm gonna do a new one ourselves. So for example, this statement means select means to search. Okay, select star means everything. From, that's the database name, if there's a database, or table, I mean table name, I'm sorry, table. Select everything from the table, but only display 10 at a time, 10 result at a time. Okay, that's just a one sample syntax. Let's say, so no NA means no such table, so I'm gonna close it. Okay, so here is another syntax that is select name only, find the name. You don't need anything else, you just need a name. From this table, go to SQLite master. Okay, where, that's the clause, where clause. The type in, okay, a table and the view, and name not like a SQL. So it's just a syntax that sets the condition, okay, the criteria. Like it's like in our Java we have the Boolean, okay, we have the Boolean. So we select the name only from this table. In this table, we want to have this to be true. This has to be true. The type in table and view, and the name not like a SQL. So that means the name does not contain this or something similar to this. Okay, so don't worry about this. We can actually we come back to do the whole thing, the SQLite statements, how to create a table, how to do search, how to do delete, how to do update. Okay, and if you want to see, if you cannot wait, you can see here, right? So here is this indicates the name. That indicates the JDBC we downloaded. Okay, we downloaded. So it's an org, that's a class dot for name, is a string org.sqlite.jdbc. And then here is which database we want to connect it to. This has to be as is. Okay, then you followed by the database name you want to connect to. And then you're preparing your statement. See, there's a Java class called a statement. This is the object. And then you use the CNN. That's the create over here. See, you create a connection. Driver manager is a Java class. It has a method called get connection. And get to connection to what? To URL. Can you see it? Right, so we're going to come back and talk about this. It's a little bit, but it's actually very simple. You provide this driver, you want to connect to this, you put this into a string and give it as argument for this, the driver manager class static method is called get connection. So then you get a connection. Once you get a connection, you can create a statement, and the statement will contain this kind of a Java statement, that is SQL statement, sorry. See, the use as string is double quotes. Those are pure SQL statements. SQL manager, the SQLite manager will understand. But those are not the Java statement. They're just a string, treated as string. Then you can do create a table. You see, create a table. That's how you create a table. So we can create a table over there. Create a table called a student table. Okay, database is called a student DB. Don't forget that's a database name with a DB in the end by convention. But this is just the table name, and we create a table. Oh, okay. The first one says if the table exists, already exists. If already exists, drop it, means destroy it. Okay. Then create a new table called a student. Create a table student. Then these are the statements. Okay. Those are statements to set up the table. How many columns? What the data type of each column? Because SQL databases use tables. Tables made of columns and rows. Okay, then the column rows will map to Java objects ultimately. So we need more time to talk about. So student ID is an integer type, is a primary key, automatic increment, cannot be null. Okay, first name is a string up to 50 characters long. Last name is also a string. This is a Java string in SQL's language. Okay, and the size is 50. GPA is double. Username is a string. Password is string. So on and so forth. Now we set up the table now. Then we just have to insert the data in there. The data goes Adam Smith. Adam will be the username. Remember, we have a username column. Smith is the password. So it goes to the password column. And then we insert a second student. Username is Bill. Password is Smith. Password is Smith. So 2 gets inserted into the table. So that's how you run SQL statement and interact with the database. Database is equal to student DB1. Okay, so it's actually pretty simple. Maybe it's confusing now, but once we have more time on Wednesday, we're gonna go over that. All right, and so this is a non GUI. This one is a GUI, and you have the main. You see, that's the main has a start, and that loads the view. You are familiar with this, right? And I don't have a CSS, so I can if I put in the VM argument. Hold on, let me get the VM argument. So JavaFX, just in case you want to look at before Wednesday. So we're gonna put that Windows argument in there. So I have to go back to here, go to run configurations, right? And make sure I have to choose the right project. That's this project. And then I have to choose my right program. That's the main. Okay, not the simple. Simple is not a GUI. So I want that. Say OK. Go to arguments. Paste that. There. Apply. Run. Then I should have a. There you go. So that shows you. Can you see? Can you see my screen? Yeah. So here's my app. Okay, basically it's a log on screen, and then you have a label here telling me my Java is connected to the database correctly. We're gonna analyze the code next time, but that's what it means. It's connected correctly, and then I'm going to log in. If I type in anything random, login says login failure. That because the database does not contain that username, that password. Remember we used the tree map, right? Before. Now we don't have that. Now it's all in this database. The database is called a student DB1. Remember that? So I'm going to copy that, or I can just drop it into my. Remember, this is my. Let me make this smaller, right? That's my. Oops. That's my manager, right? SQLite manager. So I'm going to drop this. I think. No. So I'm gonna. Can I copy? I use the drop and drag and drop. So let me go in here, and can I paste in here? So, no, I don't have a paste. So I have to make this a little bit smaller. No, I don't need this. Okay, so see if I can drop. So this is the one, drop into here. Now you see, my database can be viewed now, right? Because it's encoded before, you cannot view directly. Now you can view. So there is a username called Adam, and there's one called Smith. Okay, so this we don't need. That's the garbage. That's from before. We can get rid of that. So here is there's this table called student, and we select everything from that. Okay, so we turn the two user ones, Adam Smith, Bill Smith. Those one are legitimate user accounts. So now if I go back to here, I have to say Adam and people down Smith. Oh, it's capital S, Smith, and log in. See, login success. But if I change this to something else and then say login failure, because you connected to the database, you couldn't find a match. So that shows you worked. That's all it shows you. It worked. Though of course I don't have first name and last name. I don't have a GPA yet, which I could. Okay, and the student ID, that's the primary key. So every student has a unique ID. First student is 1, second is 2, and you can go on forever. You can have millions. You don't have to worry about any of the size, and it's automatically learn to grow. Okay, so that's a benefit of this. If you are really comfortable with this, essentially you don't need to know anything about data structures. You can just keep on using databases. But because we're computer science, we should know how databases are built anyway. Because underneath the database is using data set, the tree set, tree map, or whatever data structures. Okay, we not right now, it's delegated the responsibility to database. We don't do our own tree set, tree map. That's all. All right, so I think that's too long, and we're going to go over this. And if you want to install the extension before Wednesday, and read the tutorial if you want to, there are plenty of tutorials. And then if you can, I'm going to upload this to GitHub. And then if you want to import this into a project, then we can go over the code. It's actually pretty simple, but it's very powerful, extremely powerful. Almost all the big applications you see ever used is all database applications. So it's very important to be able to do it. That's why if you want to do this, then all your coffee stuff, your orders could potentially be put in the tables. Okay, so you don't need to decide, should I use a tree set or tree map? You can just use tables. You can create a tables. You need more than one table. I can tell you for sure. Each order, and then all the order history should be all stayed in the table too. That you, at least you need 2 tables, in other words. Okay, so I think that's it for today. It's too long, took too much of my time. All right, so that's it. I'll see you on Wednesday. All right, good. All right, see you on Wednesday.